statistical techniques in the artificial intelligence, which I preferred for your department because it's a statistics department. And since I'm a computer science faculty, I'm a computer science professor, so I know how much the statistics is important to the course of computer science. So a vast knowledge already everyone will be having, even the basic knowledge will be having at your side, like what is statistics and how the statistics is going to play the role about it. So if so that's the reason I have chosen this particular topic. One minute. Apologize for the disturbance. So coming to the today's session, like module which I'll be discussing about the statistics for artificial intelligence. I'll give you a small definition like what is statistics. So we already know that this statistics is basically a mathematical science that is going to be pertaining with respect to the collection, the presentation, as well as analysis of the data. So this presentation and analysis will help us to interpret the data because we can't understand data directly. We need to have a particular interpretation of it, like how much increasing it is, what benefit we are getting it. So such type of interpretation we need. Statistics plays a vital role for the interpretation, and we cannot leave this statistics because of the statistics, since it is a mathematical science. We cannot do anything from living across the statistics. So it is a widely used to understand the complex problem. It's not only the basic needs we are going to use the statistics, we can also be using for the complex problems we are using. And it's very helpful from the statistics, we can able to find the interpretation very easily. So complex problem will be able to understand, and those complex problems are reflected to the real world. So the statistics is going to identify the problems, and then it's also simplified to make well system to take us the decision. So we'll be calling as how the decision we are taking. So that's the reason my topic, like today's session, which we have taken for statistical techniques, how we are representing to take the decisions. So these decisions are very helpful, are very needed to understand how these techniques, how the statistics techniques are going to helpful for getting the future result, or going for the getting the decisions. So statistics are generally used to analyze the primary data. It is also used to build a statistical model, and with the help of this model, we'll be able to predict any outcomes. So before going for to start the session, let's see the outline. What is the outline over here? So we'll have an introduction to statistics, a little bit introduction. As I know, it's the statistics departments, everyone knows about it. But even though to relate the statistics with the artificial intelligence, I need to have a brief description, very brief descriptions I'll be giving it. Some of the terminology, basic terminology that is being used, which like everywhere we are using it. So we'll see that what are the basic terminologies we are going for it. Then how we are going to categorize the statistics, because categorization helps us to go for the classification. Yes, so categories in the statistics, there are many two major categories in the statistics, and after the categories, how this descriptive and inferential statistics helps us to find out the result. So we have the statistics. With the help of the statistics, we can correlate our data. So a correlation is needed. That is a formula. It is there with the help of the correlation, covariance, and regression. Such words are already known to it, but these is being used in the research area. These are being used in the computer science also. So we have successful techniques for the artificial intelligence, how these techniques are implemented in the artificial intelligence, and based on that, directly I'll be moving to the some of the algorithms of the AI which are firmly used, and it's like rigorously used. We will say that it's rigorously used everywhere using the statistics. And finally, we will end up with the conclusions. So let's go start with the first one, that is the statistics, and I have already given it like the definitions. So let's see through it. What is the definition of it? So statistics is basically, I said, it is a mathematical science. So it is a branch of mathematics that is going to deal with the data collection and organization, data collection as well as the organization of the data, analysis and interpretation as well as presentation. That is most important, interpretation and presentation, because sometimes we'll say that like interpretation is very important. Until unless you won't interpret it, you won't able to present the data. Okay, so that is the reason statistics will help us to interpret, because every individual interpretation is different. Okay, like if I'll give you one very small example, uh, glass is filled with the water. Okay, so if the glass is full with water, so some people will say the glass is totally full, and some people will say that the we doesn't have any space to fill any more water. Similarly, the glass is half filled with the water. So some people will say that a more amount of water can be filled into the glass, and somebody will say that no, only the half of the glass is filled. So this is called as the interpretation, and the way we interpret, the same way we are going to present it. So that's the reason statistics plays a vital role on the interpretation as well as the presentation. It is used to process complex problems. I'm not saying about the simple problem. We are talking about the complex problem. We all have heard about it nowadays. The statistics are everywhere used. Like for example, cancer, the disease, medical problems, the cancer problems are being detected. Okay, how we are calculating it, how we are finding it out, the particular patient is having a cancer or not in the medical science. Similarly, like if we say for the weather forecasting, how we are saying it, like whether tomorrow it is going to be rain. So what the statistics is going to play. So this is the reason the interpretation presentation plays a really vital role to process the complex problem in the real world, so that the analyst can look for meaningful trends and changes. Now, the word has come as the analyst. Who are the analysts? So, analysis, those who are doing the analysis, those who are interpreting it, they are called as the analyst. Analyst can be anyone. Okay, analyst can be anyone, even a normal user, even who is writing the code or who is using it. Anyone can be the analyst who can interpret, who can give the meaningful trends, who can see the changes, who can interpret the changes, and based on the changes, we can make a decision. Analysts generally reviews the data so they can reach the meaningful conclusion. And several statistics functions, principles, and algorithms are being implemented to analyze the raw data. So building the statistical model and infer infer about the result is main task of the statistics. Is the main task of the analyst to use the concept of statistics. So the field of statistics has an influence. Okay, so with the help of the statistics, we have like major role of the statistics. We can analyze the data. Based on the analysis of the data, we can build a model, and with the help of those model, we can infer the result. So statistics generally not only used in daily routines, but in many like has an influence overall. Overall, you can say that all the domains of the life, all the domains, whichever the domains you are taking into it, whichever it is coming into your mind, it will come there itself. Even I can say that a small student of second standard and third standard, we won't say as the second standard, third standard. You just take the age group of 2 years and third year of kid. Even they also interpret. Okay, so if you have seen so many toys are given to the kids, and we'll be saying that put it in a sequence order. Okay, or we will say that if we give them the different colors of balls to the 2 years kid and 3 year kids, and we'll make them to interpret in such a way that, like, not interpretation, we'll say that classify those balls into the colors based on the colors. So those two years kids and 3 year kids, what they have knowledge, they doesn't have knowledge, they are interpreting it. Yes, they are interpreting it. They're the rules play of the statistics. Now you can understand how basically it is working as, how basically it works as even a small 2 year kids who doesn't have any information, prior information is not there. He doesn't know about what decision has to be taken, but the mind can able to use. Okay, so with that, let's move on the basic terminology regarding the statistics, like how it is being used. So I already suppose that, like, where the statistics are being used, what are the domains? You can check it out at my slide, which is available at your side. So domains can be the stock market, the life sciences, weather forecasting, retail management, educations, insurance, and media. It's unlimited. Okay, so coming to the further moving towards the statistic role of the statistics, we'll see about the basic terminology, what the basic terminology is used regarding the statistics. So these words are very familiar at your side, like what are this terms are used. So there are few statistical terms which everyone should aware of it. Everyone should aware when we are dealing with the statistics. Okay, so these terms are like called as population, sample, variable, parameter. So a very brief description I'll be giving on these terms, like what is population. So population is generally like it is a source set of sources from which we are collecting the data. So how can we say that we are collecting the data? What type of collection it is? So it can be anything. The class of, like, number of students in a class. We can say that number of students in the class, or we can say that what is the population of a country. Yeah, or we can say that how many apples are there in a bag. Yes, or we can say that, like in a chessboard, how many the chess keys are there, how many the black keys, and how many are the white keys are there. So they, whatever the interpretation, if you're saying the set of data, okay, when we call as the set of data, those are called as the population. Coming to the next term, that is sample. What is a sample? So generally the sample is subset of the population. So we'll say the subset of the population. What do you mean by the subset of the population? So subset of the population means it is the chunks of the population. Some small part. Chunks means some small part of the population. Okay, so it is generally represented as a subset of wide population. So we basically take sample of the population, sample sets. So when I'll be taking the words, the sample data or the set of the data or the data sets, when I'll be talking about the algorithms. So because in computer science we are frequently using the word as a data set. So data sets, collection of some data. So that collection of data is called as a population. Okay, but what type of data it is, so it will become as a sample. So we apply this statistical model to them and find out whether our conclusion holds on an entire population or not. Like, we will try to like interpret those data, and with those interpretation of data we will try to get some conclusion. Now with those conclusion we will be saying that will it belongs to that particular population or not. Okay, so coming to the next word, like the next term, which is called as variable, which is also very basic terminology that is used in statistics. So variable is any characteristics or the number, or you can say that the quantity that we are going to measure or count it. So counted words, or we can say that like something like how many female students are there in the class of the given class, how many female students are there. Similarly, how many male students are there in the class. Similarly, if we can say that like what is the age group of the students in a particular class. Okay, so wherever we are getting some quantity, then it becomes as a variable. So variable also, it means that varies. It's not, it cannot be a constant number. Okay, it will be a varies. It will be having a range of numbers. Okay, so it will be ranges. It will be like it cannot be a constant number. It is. I hope you are able to understand. Okay, so when it comes to the population, we say that it can be anything of like data, anything of the number, like the gender, the age, region. You can say the language, how many students were speaking English in the particular class, how many students who can speak French language in the class. Okay, like that we can say that. So language based on the time, degree, ethnicity, anything, height, weight, anything that can be the quantity can be considered as a variable. So variable may also be called as a data item. They can be any data or data item. Item means the set of data. Coming to the next one, that is the basic terminology of the statistic, which is the last one, which is called as the parameter. So what is parameter? So parameters are also known as statistical model. So how it is going to represent to the statistics? So it can be says as like the mean or the summation or any element of the sample data set. So any element of the sample data set. So basically, gives us the characteristics. It will give us the characteristics. It will give us some idea about the population and the gender. So it is generally known as a statistical model. Statistical parameters or the population parameters are generally called as the quantity that indexes a family of probability distribution. So these are the basic terminology what we are using for the statistics, and everywhere it is like global to be known. Everywhere it should be known to it. Now, moving forward, like after going for the terminology, because we'll be repeatedly using this all terminologies, we'll be moving towards like what is the types of analysis done in the statistics. So, on the basis of the analysis which we are doing, it is one of the two ways, that is quantitative analysis and qualitative analysis. So, we'll say that what is quantitative and what is qualitative. So, with the words itself, we can able to understand what is quantitative. Quantitative means some numbers, which is clearly defined some numbers. So, quantitative analysis, it is a statistical analysis, is a science of collecting, interpreting the data with respect to the numbers. With respect to the numbers means clearly we'll be having some numbers. Okay, so with clear to the numbers, and we can say that it can be defined as a graph also to identify patterns as well as trends. Okay, why? Because if we take huge amount of data, na, we won't able to understand. Our humans brains are made like that. Like we can't able to understand the numbers easily. Okay, when it is a small set of data or a small like you can say that 10 rows of data or 25 rows of data, it's easy to understand. 100 rows of data also very easy to understand. But if you want to predict something from those hundreds of data, we need to have representation of graph, because our human beings are easy to understand those graphs easily. Visualization is done very easily to the human beings. That's the reason whenever we have a quantitative data, we will interpret in the form of graphs. Whereas coming to the qualitative of the data, so it is also a non-statistical analysis, which is given as a generic information. Okay, so what are this generic information? So generic information can anything like text, sound, or any forms of media. So let me give you one small example for this quantitative and qualitative. Like suppose I will be going to a coffee shop. So there in the menu card it is mentioned as the coffee is available in form of like coffee is available in the menu card as large, medium, and small. So how can I understand? Like it is, I should go for the large, or I should go for the medium coffee, or I should go for the small coffee. With with small cup of coffee or with small a medium cup of coffee should I prefer? Okay, so this here we are not able to understand. We are just saying that a small cup. That small cup doesn't have any quantity. One cup which medium. Okay, like sometimes we'll go for it. Like we will go for the ice cream. Say that we need a big scoop of the cup. What is that big scoop? What is the quantity? We doesn't know. So wherever it is defined such words, the vague words that will be called as a quality. Now, the same example for the coffee shop. If I'll say that there is a sale for the coffee shop, like if they have regularly they have a sale of 50 numbers in a week. So this is going to define very well that in a week that particular coffee shop can able to sell 50 numbers of coffee. 50 numbers of coffee. Okay, so very clearly define that the number is what is that number? That is 50, 50. That is 50. So it has a perfect number. It has perfect number, and that we need to understand that we also need. So how this is going to represent? It is representing the through the help of the statistics. Although the quantitative and the qualitative both have this analysis, both have its own analysis, and they are giving the same analysis. Their interpretation is done in the same manner. Okay, to provide the final result, final output, or the conclusions, we'll be getting as the same conclusion. But the more clear idea will be given through the quantitative data. Yes, so quantitative analysis provides clear picture and as well as the insight of the real world. Insight means what is there inside, like how it is representing, what trend it is going, what changes are going. We can able to understand with the help of numbers. So it is a characteristics to make crucial to the analytics. That's the reason we need this. And for this only we are interested. Why we are interested? Because it is giving me very clear idea like how the changes are going to be done, whether it is positive, whether it is negative, whether it is increases, whether it is profit, whether it is loss, like how much profit it is, how much loss it is. This quantitative data can able to give it, and that's all we will be interested for it. Everyone is interested for that. Okay, so that's the reason we'll be focusing more on the quantitative data. So moving forward, this analysis can be done on the quantitative as you can see in the slide also. So it is basically quantitative is a statistical analysis, science of the collecting and interpreting the objects with respect to the numbers. With respect to the numbers, just have a clear idea about it. Coming to the qualitative, it's a non-statistical analysis and mostly deals with the generic data using like text, sound, okay, pictures. Okay, so you would have heard about it. Like, what is the pixel of the pics? It is a JPG format. It is a PIC format, or it is a media format, like a different format. It is. So we are not clear about it. That's the reason it will be called as a qualitative. Now, coming to the categories in the statistics, so we broadly classified this statistics into two different parts, that is called as descriptive as well as inferential. So, what is the descriptive and what is the inferential? So, we can check it out. The definition is very clearly given. Descriptive statistics uses the data to provide descriptions of the population, what type of population it is, either through the numerical calculation or you can say that the graph or the tables. With the help of the graph also we can have, with the help of the table also we can represent. So wherever the descriptive, okay, very clearly the data has been represented, that will be called as the descriptive. Now coming to the inferential statistics, so it makes the inferences as well as the prediction about the population based on the sample data, based on the sample of the data that will be taken from the population, what the population it has been given. So we can able to have a prediction from it. Okay, we can able to have a prediction from it. So this method is mainly focused for the characteristics of the data. So it provides a graphical summary of the data. You can check it out how the data has been given here. So it is graphically represented, pictorial representation is being given. Okay, so we'll see that, like you can see that how many cylinders are over here. We have 4 plus 4, 8, like 4 dark blue color and 4 light blue color. So this data is being given over here. This data is being the sets of population it is given over there, and the characteristics of the data is it is divided into two different way like dark blue color and the light blue color it is given. So this is a description characteristic of the data which has been described clearly how the data is been represented over here. The same data can be taken in the form of like if we'll take the example of height of a particular person, then we can represent the descriptive statistics as maximum, average, or the minimum. So minimum height of a person in a given population, average height of a particular student in a given population. Similarly, the minimum height of a particular person in a given population. Okay, so this is called as descriptive data. Coming to the inferential, so it is generalizes the large data set and applies the probability to draw a conclusion. Why? Because inferential, with the help of the inferential, we will come to the conclusion. We will able to conclude with, we can able to come to the core part. Okay, so it allows us to infer data parameters based on the statistical model what we are using for a given set of sample data. So you can check it out. Again, the same example I have taken here. Like total 8 items are there. So inferential statistics, it is given here. Like process the step based on the choices, based on the decision, whether you wanted to take dark blue color of the cylinder or the light blue color of the cylinder. Based on the decision, question marks will be given, and based on that, we will be coming to the conclusion. So you can categorize this data. Yes, we can able to categorize the data. Whatever the data is here, total 8 item sets are there. So 8 item sets can be divided into 2 different data sets, which contains 4 data items that is of blue, dark blue color, and similarly another data set we can have 4 item set which is of light blue of color. So similarly, the same example for the height, if I take like inferential, if we wanted to have, like we will try to infer the data from it, from the height of a given person, then there what we are doing it, what we are checking it out, like what is the maximum size, what is the minimum size. Okay, so here we will be saying who is the taller, who is the taller. Okay, so taller of a person in a given population of the data set, similarly the average, and like the lower one we will be going, or the minimum one will be going for the short. Okay, so this way we will interpret the data. So generally this inferential statistics is help us to draw any conclusion, like we will come to the conclusion. Okay, so descriptive statistics have some statistical measures. So what are these measures over here? We'll use with the help of some use case. We'll see one use case I have kept over here so that we can have a clear idea about the descriptive statistics. So how this descriptive statistics is given in a given use case. So here you can see that it is a sample data set for a given car. So this is my data set is given over here, which containing the variables. Okay, so what is the variables over here? We have cars, we have a mileage per gallon, cylinder type, then displacement, horsepower, as well as the real axle ratio, which is also called as drag. So using this descriptive analysis, we can able to analyze each of the variables in the given data set, such as the mean, median, mode, standard deviation, minimum, maximum. So such variable, such interpretation we can able to do. So there are few statistical terms also that will be used in the statistics, and we must aware about those terms, that is mean, median, mode. Okay, so they are also called as the central tendency. They are called as the measures of the center. Okay, measures of the center. So central tendency also it has been known. Is it clear? Central tendency also it is called. So we will see through it how the mean can be calculated. So for the same given data sets, if you want to find the average horsepower, okay, average horsepower of the car, where is my horsepower? So this is the fifth one, fifth column, you can check it out. So the horsepower of the given car among the population of the car, we will check that how to calculate the average of all values. So average of all values, what we are doing it, we are taking all the data items set divided by total number of items, total number of items. So you can check it out, 110, plus 1, 110 plus 93 plus 96 plus 90 plus 110 plus 110 plus 110 times divided by how many are total number of data items are there? That is 8. So my average value is come as 103.625. Similarly, we can also calculate the median. So what is my, we can calculate the mean. So what is my mean? It is a measure of the average. Why we have done in the last one, here we have calculated the average of all the values. Okay, so this average of all the values is going to give me what? It is going to give me the mean of it. Okay, so measure of the average of all values in a given data sets or given sample is called as mean. Similarly, we'll go for the median. So what the median is going to do is median is going to calculate the higher and the lower range. Okay, the higher and the lower range. So if you find it out the center value of the MPG, see the second column of the data set, that is the MPG among the population of the cars. We will arrange this in the ascending order. We will first do it in the ascending order. So you can check it out in the given here. I have made it in the like ascending order. So the data which represented here in this second column is represented here in the ascending order. So in this case, we are having even entries. So suppose if it is odd entries, so n minus 1 we will do. Okay, so but in case of even entries, we take the average of two middle values. Okay, so what is my two middle values? That is 22.8 and 23. So we'll calculate the median of it. Okay, this is going to calculate the median of it. So 22.8 plus 23 divided by 2, which gives me as 22.9. So median of the given data set for MPG is 22.9. So what is the median? So median will be called as the measure of the central value of the sample set. Central value of the sample set. Now coming for the mode. So if you want to find it out most common type of the cylinder among the population of the cars, we will check the value which is repeated most number of times. So we'll see the third column of the given data sets. This is the third column of the given data sets. So what is the repeated data sets? How many times a particular data sets are repeated? You can see that we have only two values, that is 4 and 6. So that's the reason the mode is taken as 4 and 6. Okay. So what will be the mode over here? The value most recurrent, like the repetitive one, most repeatedly it is coming. So the value most recurrent in the sample set is known as mode. So few more statistical terms are there, like if we go for the measures of the spread, because after going for the terminology, we'll be having the central tendency, and based on this central tendency, we have some spread, the distribution. The spread is called as the distribution. Okay, so this distribution, the measures of the spread are range, interquartile range, variance, as well as standard deviation. So we see one by one what are this, how it is representing with respect to the statistics. So we can see, you can see that in a slide, given slide, like range is the given measure, how spread apart the values in the data set. So this is my formula given. The formula is also given over here is range equals max of xi minus minimum of xi. So range means it will be the lower range. We actually have a range of two sets. Okay, we will be generally having a two sets. One will be called as the lower side and one will be called as the higher side. Or one will be called as the maximum side or one will be called as the minimum. The other side will be called as the minimum side. So range will be calculated as higher minus lower. Okay, higher minus lower. Similarly, the maximum minus minimum. So maximum xi will be the number of data sets. I can be the n numbers. So maximum of x of I minus minimum of x of y. Now coming to the interquartile range, in the range itself we have quartiles. So it is divided into the four quartiles, Q1, Q2, Q3 and Q4. So generally if we talk about the interquartile range, we only represent among the Q1, Q2 and Q3. So you can see that for the Q1, Q2 and Q3, what is the range? If we calculate the range of the Q1, what is the lower range? What is the minimum range for the Q1? It will be 2. And what is the highest range? You can check it out. Sorry, it will be 1 and the higher range will be the 2. So we'll see that what is my range over here for the same example I have taken here. So Q1 can be taken as 2, which is the lower range, 2, higher range is 3, because Q1 is represented over here. So 2 plus 3 divided by 2. Similarly, if I talk about the Q2, so Q2 is where it is lying in between 4 and 5. So that's the reason minimum range and maximum range. Okay, so 4 plus 5 divided by 2. Similarly, I'll be calling for the Q3, so 6 plus 7 divided by 2. Now, if I talk about the Q1 and Q3, this is Q1, Q2, Q3. If I want to calculate for Q1 and Q3, so Q1 represent here is Q1 here represent is at the lower level as 2 and 3 is Q3 here. Okay, so interquartile range can be taken as from 2 to 7. From 2 to 7. After the interquartile range, we have another term which is called as variance. Variance has a vital role played in the statistics. Why? Because variance describes the random variables. Variance itself, the word itself says that which keeps on varies. Okay, whenever the data which is keep on varies, whether it is positive sides varies or the negative sides varies, we have to infer about it. Okay, but it has a random variable. It doesn't have a constant variable. It has a random variable from its expected value. So it entails computing about the squares of the deviation. So generally, whenever we talk about the variance, we generally calculate the deviation. Okay, so how much deviating? Because variance is my random variable. So if what random variable means something changeable variable. So how much change it is there from one data to the another data? How much deviation it is there? How much it is different? It is over there. Okay, so the deviation will be defined as the difference between each element from the mean. So we have seen there the mean, how we have calculated the mean. Yeah, did you remember? The mean is the average. So the mean will be defined as a mu value. So deviation is the difference between the each element from the mean, and deviation can be calculated as xi minus mu. So what is my xi? Each data item in a given data set. Okay, each data item in a given data set. So xi minus mu. What is mu? Mu we have calculated as a mean, which is my average. So whatever the data we are having is that data differentiate minus subtracted by the mean value. Similarly, the population variance is the average of the square deviation. It can also be like represented as sigma square. So if we talk about the total population, if we talk about in the population, then this can be calculated as the same population variance can be calculated as sigma square equals 1 by n summation of I equals 1 to n. That means the I value, the number of item sets equals xi minus mu the whole square. Okay. So this is my population variance. When I am talking about the population, when the data item is in a given population, in the form of population. Similarly, if I say some sample of the data, if I say some sample of the data, so sample of the variance will be termed as average of square difference from the mean. Okay, so here you can take it out sigma square, which is the population variance, representing it as a sigma square. Here the sample variance will be represented as s square. Okay, so here you can take it out 1 by n. 1 by n means the total number of population. N is the total number of population. Since it is a sample of those population, a small set of population is taken. Is it clear? A small set of population is taken. So that's the reason n minus 1 here. So it will be the same as 1 by n minus 1 summation of I equals 1 to n, that equals xi minus x whole square. So mu will be there, here the mean it will be there, and it will be taken as a x bar. That is also called as a mean model. Then we'll move towards the next term, that is called as standard deviation. Yes, the standard deviation also plays a vital role. With the help of this variance and standard deviation, we have number of algorithms that are being used in a computer science area. So this standard deviation is the measure of the dispersion of the set of data from its mean. So how much it is being dispersed. Okay, so it is going to calculate. It's going to calculate the dispersion of the data, set of the data from the mean value, from the average value. So the formula it is given over here as this sigma. It's not square. Sigma square. Sigma square will be represented as population variance. Okay, Okay, so the standard deviation will be written as sigma equals 1 by n summation of I equals 1 to n equals xi minus mu whole square. Or you can say that sigma is equal to square root of variance. This is the formula of the same formula. You can say it as variance also. So square root of variance. So we'll see one example over here. One small example I have kept here to understand the mean, median, variance as well as the standard deviation. So use case I have taken as our person which is whose name is Ross has 20 dinosaurs figures. So 20 dinosaur figures are represented over here. You can see it out. 20 will be in the 20 number. So they have these numbers and we'll work it out for the standard deviation. We'll find it out for the standard deviation. So what is the first like term we are going to use? We will first find it out the mean of the given samples. So what is the mean? We have to add all the numbers divided by total number of given numbers. What is my total number of given numbers? This is 20. And just do the summation. So total summation it will be done and that will be represented as mean value will be 7. That is mu equals 7. So that means now I am not saying the word as an average. I will be saying the word as a using the word every time as a mean. Next one, after going for the mean, we will be calculating for the standard deviation. So when we going for the standard deviation, we have to calculate xi minus mu whole square. So what is my mu value? What we have got the mu value? Mu value is my 7. So now xi minus mu whole square. So what is my xi? The first value is 9. So 9 minus 7 whole square, that is 2 square equals 4. Similarly, 2 minus 7 whole square, that is equals minus 5 whole square equals 25. So then for each number subtract the mean and square the result. Now one more like question can be come to you when why we are doing the square. What is the need of the square doing it? This question should be raised by the student. Yes, why we are going for the square? What is the need of the square? Is the only formula given and then we are using it? No, it's not like that. Why we are using the square means we don't need negative numbers. It's clear. We don't need negative numbers. We always wanted to have a positive numbers. If negative numbers are there, then my interpretation and my conclusion will go in a different direction. That's the reason we always wanted to have a positive value. Is it clear? So that's the reason we are using as square of it. So whenever we do any square of a negative number, it will be a positive. Yes. So that's the reason we are using here the square. We have to understand why we are doing for that square. Is it clear? It's very small thing to be represent to understand. So we'll calculate for every data set like 20 data items are given over here. So some of the few only I kept over here. At the beginning you can able to calculate. So what will be my result? Finally the result will be 9 minus 7 is 4. 2 minus 7 is 25. 5 minus 7 is again 4. Similarly 9, 25, 0, 1, 16, 4 and goes on up to the last one, the 28th item. So then we work out for the mean of those square differences. So now we will be going for the square of the differences. So we have already found the values. Yes or no? We have already found 4, 25. How we got it from here itself? Yes, you remember? So this particular square differences will be again doing the summation of it divided by 20. That will give me my sigma square. That is the population variance. That is my population variance. So sigma square equals 8.9. So we got the value of variance now. Now what we have to find it out? We have to find it out by standard deviation. What is my standard deviation? I have said it. What is my standard deviation? You just take the square root of the variance. So my variance is over here 8.9 and just take the square root of it. You'll be getting. So same value. This is the variance formula. You can check it out here also. The variance formula, same variance formula, and then I'm calculating the standard deviation as the square root of the variance. So that is my 2.983. So my for the given data sets, what is my standard deviation? It is sigma is equal to 2.93. Now after coming from these all terms, will directly move a little higher up for the statistics, which are very much using in the computer science application. That is the correlation, the covariance, and the regression analysis. Some of the things I have skipped over here so that I wanted to make the statistics to understand the field of the computer science, because now we all are using the computer science area. We every individual is represented with the computer science of area. Okay, so we can't escape from it. That's the reason I wanted to say like how the statistics plays a vital role in the area of the computer science. Okay, so some of the things I have just skipped over here so that I can map my the statistics to my area. So we'll see that what is a correlation. So you can say that the correlation is come with the two words, that is co and the relation. Co is called as a together. Wherever we are making its integration or we are doing the integration part, that is called as co. We term it as a co. And relation means some relation. Some relationship, whether it is positive relation, whether it is negative relation, whether it is increasing way of the relation or the decreasing way of the relation. Okay, in whether it's strong relation, whether it is weak relation, some other way, some relation we can able to interpret. Okay, so when two sets of the data are strongly linked together, then we say as highly correlated. And similarly, when we say that two sets of data are weakly linked together, then we say that is very low correlation. Okay, very low correlation. Okay. So the correlation can be termed as positive as well as negative. So a value that will be increases throughout the way, then it is called as positive correlation, and the correlation which is keep on decreasing throughout the way, then it is called as negative relation. So we won't say that this negative is my negative term. Okay, we are saying that it is just decreasing. The values are decreasing. Okay, so whenever the values are decreasing, we say as a negative. And whenever the values are increasing, we say as positive. So we'll see with this example, because these examples are very important for the computer science background. So correlation generally termed as a linear only. Why? Because it will be represented in the form of lines. It won't be in the form of scattered. Okay, it will be in the form of the lines. So that's the reason it is termed as linear. The correlation have three values, total three values. One will be the plus one, 0 and minus 1. That means the correlation values lies between 1 and minus 1. Okay, so whenever the correlation values lies towards the 1, we say it as positive correlation. And whenever the correlation lies towards the minus 1, then we say it as a negative correlation. Okay, so we can see that the perfectly positive correlation, the data is increasing. Similarly, high positive correlation is all the data are moving towards a positive direction. That's why highly positive correlation. Now, low positive correlation, it is also positive, right? Because we can see that it is in the increasing order. But every data is not moving towards the increasing side, towards the increasing way it is not moving. That's the reason we call it as a low positive correlation. Sometimes we won't have any relation, neither the positive, neither the negative, neither the increasing order way, neither the decreasing order way. Just the data are kept in a scattered way. So there we don't have a relation. Okay, we can't keep any relation. So such relations are called as no correlation, and it will be represented by the value as 0. Okay, so coming to the low negative correlation, it will be minus 0.5. So since it is a negative relation, that's the reason we use the value, we use the uh, minus value. Okay, we use the minus negative interpretation will give. So minus 0.5. Similarly, if we have a high negative correlation, so it is decreasing value. It is towards the decreasing value, and since all the data are moving towards the decreasing way, so that's the reason it will be highly negative correlation. And perfectly means all the data lies in the same line. Okay, all the data lies in a decreasing value of the line, so that's the reason perfectly negative correlation. The values will be showing as how good the relation is, whether it is positive or whether it is negative. So this correlation can be taken as a equation, can be termed as a equation which can be taken from the standard deviation. So we have seen the value like S can be represented as the square root of the variance. Yes, you remember square root of the variance. So sample data sets, since it is a sample data set, that's the reason it is n minus 1. So we'll see that how the correlation will be taken as. So R of x comma y, there are two values x and y. So it will be represented R is my correlation value. So R is my correlation value of the two data items will be taken as summation of x equal 1 to n xi minus x bar. X bar is my mean value, yi minus y bar, y bar is my again mean value divided by summation of I equals square root of summation of I equals 1 xi minus x bar whole square and summation of I equals 1 yi minus y bar the whole square. This is the formula of my correlation equation. You see, I suppose I have given one, yeah, I have given one example over here. Okay, so to make you understand how the correlation can be. Why? Because we are writing the algorithms for them. Okay, we can able to correlate with the help of the algorithm. We can able to directly come to the conclusion. We don't need to see the data sets and simple. You just give the data set to the algorithm and it will give you the conclusion. Is it clear? Nowadays we are not going to calculate everything. We are just writing the algorithm and we will just provide the data sets based on the algorithm, whatever it is written, give you the conclusion. Yes. So the example I have taken here as for ice cream sales. So what will happen if the sale of the ice cream, if we are seeing, if we are like suppose if you're going for the shop, you'll see that there will be a huge sale of the ice cream during the summer time. Yes, during the summer time there will be huge sale of the ice cream. Similarly, there will be a little bit low sales when the temperature is low, or you can say that the season is of winter season. So I am having here the data sets here. I have taken the data set. That's the reason I will be using the term that's the data sets. Now the sample what we are using in our statistics, that sample will be termed as a data set over here. Okay. So I'll be keep on using this words like data whenever I'm saying the data sets, you can able to understand it is a sample of the given population. Sample data set of a given population. So this is my data sets over here. So ice cream sales versus the temperature. So you can check it out by seeing this particular data sets. The temperature is increasing, the ice cream is also keep on the sales of the ice cream is also keep on increasing. The temperature is decreasing, the value of the like the sales of the ice cream will also decrease. So it is represented in the graph format also. You will see that whenever the temperature is low, the sale is also low. Whenever the temperature is more, the temperature is keeping on the increasing side, sales is also moving. Okay, we can see that it's increasing when the temperature increase towards the x-axis, sales is also keep on increasing towards the y-axis. So we can easily see that the warmer weather and the higher sales go together. So relation is good, but not perfect. Okay, so relation is good. So we can able to calculate for this given data set, we can able to calculate the correlation. So you can check it out. I have given here the correlation of the given data set is 0.95 centimeter. But how I have calculated? How I have done? That is the question. Like fine, my correlation is given as 0.95, and since there is no minus term we use over here, so it's my positive correlation. Okay, it's my positive correlation. So it's my positive correlation, that is my highly positive correlated. You see that highly positive correlated with this particular data, with this particular value. Okay, so how do I have calculated? So we'll see that one small calculation I have made. So this is my temperature given. Yes, this is my sales given. Now first what I will do? First I will find it out the mean value. Did you remember the mean values? The average value. So first I will calculate 14.2 plus 60.4 plus 11.9 plus 15.2 up to plus 17.2 divided by total number of the item. Okay, so we got as 18.7. Similarly, I will calculate the mean value of it. Yes, I will calculate the mean value of it, of the sales. So similarly, I will calculate 215 plus 325 plus 185, so on up to 445 plus 408 divided by total number of the items. So that I got as a mean value, that is called as the 402. So now what I will do? I'll be taking the standard deviation. So what I will do, I'll subtract x minus mu, x minus mu. Okay, xi minus mu, did you remember? So 14.2 minus 18.7, I got some value. 16.4 minus 18.7 minus 2.3. Similarly, 11.9 minus 18.7 minus 6.8, and it goes on. Similarly, I will calculate for the sales also. That is my B value. Okay, that is my B value. So I'll calculate here. So again, how it is? 215 minus 402, I got minus 187. Similarly, 325 minus 402, so I got minus $77, and this goes on. But you can see that somewhere we have got a positive value and we have a negative value. But to understand, I have said that why we are using the square value. We were doing it in the variance, we were doing it square value. We are always doing it. Okay, xi minus mu the whole square. Why? We don't require the negative value. If we take the negative value, our inference will goes wrong. Inference means the conclusion. The conclusion will goes wrong. Okay, so to calculate the mean, after calculating the mean and getting the sum up of it, I will able to calculate my standard deviation. I can able to calculate my standard deviation. So calculation of the standard deviation is, first I will calculate A into B. I'll do the value of A into B. I'll multiply the value of A and B. I'll go for A square of all the values, similarly B square of all the values, and then again get the mean of it. Okay, get the mean of it. And then put it into the value, put it into the particular, this is this is my formula. Okay, put it into this formula. Okay, so this multiplication is there na, A into B. So that is only A into B, summation of A into B. Is it clear? Summation of A into B. I have done here. Summation of A into B divided by square root of A square multiplied by B square. So I got the value as 0.95. Now you can check it out. My value is highly correlated. Is it clear? Highly correlated. Highly positive correlated. We say the word is highly positive correlated. Now, moving towards, like, there are some other words which is called as variance, uh, covariance, and correlation. Variance we have seen. Similarly, with the help of variance, we have a covariance and then the correlation. So, how they are related to each other. So, whenever I was saying as the positive value and the negative value, the plus value and the minus value, they are called as the magnitude. Is it clear? They are called as the magnitude. So variance tells us how much a quantity varies with respect to the mean. So mean value will be there, like average value will be there, and how much my individual value is going to be varies. How much far it is, how much closer it is. So it's the spread of the data around the mean value. So whatever my mean value is there, if I'll represent it in the graph, wherever I'll keep the value, mean value in the center point, and whatever the values I'm getting of xi, that means all the items, I'll be putting here the far, like distance I'll be calculating. So we only know the magnitude over here, as in how much the data is spread. So magnitude can be the positive or the negative. Now, if we talk about the covariance, it will tell us the direction in which two quantities vary with each other. What is the direction? Positive direction or a negative direction? Similarly, if I talk about the correlation with respect to the covariance, then it shows us both the direction as well as the magnitude. So variance is my magnitude, positive, negative, plus or minus. Direction is my moving direction. Okay, whether it is upward or whether it is downward. And whereas correlation is showing me both, whether it is positive direction towards the upward side or towards the negative side. Similarly, the magnitude, positive as well as the minus. Now moving, these all terms were taken from the statistics. Directly it was taken into the statistics. And now I'm jumping towards the statistical techniques to the AI. Why? Because I wanted to make you to understand how the statistics, because uh, without the statistics, we can't do anything. Now we are using the mobile phones, the robots are there, the robotics are there, the artificial intelligence are there, the neural networks are using. All are based on the statistics. Is it clear? So that's the reason you can the statistical techniques how for the AI how it is being used. Okay, so this AI application started with the using of the traditional statistics techniques itself. We must understand the straight line interpolation. So I have not given you, I have just given you the correlation like my line should be linear. Okay, so we have to interpret here also how the straight line interpret my data to predict for my future value. Prediction is for future value. So whenever we are predicting, we are doing prediction for the future only. Na? Yes. So like how the statistics is going to help me to come to the conclusion. There are several other such statistical techniques which are successfully applied in the developing so-called AI programs. So we say such so-called is used as AI program. They are called. Why? Because the statistics techniques are called as the AI programs. We have today, we are using much more complex, not only the small one, we are using much more complex terms, and with the help of the statistical techniques only we can able to predict. Yes, so we know that we can able to understand tomorrow the it is going to be rain or not. Or like suppose after 10 days you wanted to go for a vacation. So that day the reservation is there at a particular flight or not. Or that day the reservation is there by any means of transport you are going in, that reservation is there or not. We wanted to predict, we wanted to see, we wanted to check. Okay, so some of the basic examples of the statistical techniques which are uh, like vastly used in the AI application is the regression, classification, clustering, probability theories, as well as decision trees. So these these applications we are using it in the AIs. Is it clear? But it is basically from the statistics. They are basically from the statistics. They are not the part of the AI. They are not the part of the computer science. Is it clear? So that's the reason the statistics plays a vital role. Without statistics, we can't uh, predict anything. We can't predict anything. Anything. If you wanted to see that, what is the score of a cricket? If there is a cricket match is going on for two teams, so who is going to win? We predict. Yes, we predict whether which particular team is going to win the match. Yes, similarly. So this is based on the statistics. So we'll go through slowly like how the AI is represented. Only a very few I have represented here which are widely used in the AIs. That's the reason. Some only very few algorithms I have used, but there are number of applications. There are number of algorithms that are being used today in the computer science area. So, artificial intelligence is basically a technology that helps us to create intelligent system. Okay, so why I have taken the topic as like artificial intelligence? Because everything has now changed into the intelligent system. Everything. Like suppose you are doing a walking. Okay, so how many steps have you walked? Did you calculate, or did you keep on whenever you're working, you're calculating your steps? No, you can check it out in your mobile phone. Like at the end of the day, how much you have walked, how many kilometers you have walked, or how many steps you have walked. This is an intelligent system. This is an intelligent system, which is a part of the artificial intelligence. Okay, so this simulation is done for human being. So every simulation what we can do for the human being with the help of intelligence, artificial intelligence, with respect to the statistics. So a very clear example, one word is called as the machine learning, because machine learning is a subset of the AI. Is it clear? Machine learning is my subset of the AI. AI is the vast term, and in that we have machine learning, we have deep learning, we have IoTs, different words will be taken. But overall, if you say that it is a big area of AI, artificial intelligence. We have neural networks. So many things you'll be hearing it. ANN, artificial neural network, CNN, computational neural network. Such words will be keep on hearing it, but they are just the subset of the AIs. They are just a subset of the artificial intelligence. Okay, so that's the reason the common examples, the common algorithms I have kept in today's module. So what is this machine learning? It is a subfield of the artificial intelligence which enables the machines to learn from the past data, experiences itself without being explicitly programmed. So what the machine intelligence are doing it, what the machine learning is doing it, what it is doing it itself learn from the past data. The history data is given, the sample of the data is given. Now with those sample of the data, we'll use some statistical techniques such that my system can itself try to learn itself and a new data can be represented, or a new data can be interpreted, or a new data can able to give me the result. Yes, is it clear? So we are not writing every day the same example. If I'll give like how many steps did you walk in a day, your mobile phone can able to calculate. Yes, you can check it out. Every multimedia phones nowadays, every multimedia phone is giving you at the end of the day at 10. If you fix the time at 10 p.m. in the night, you will able to see that how many steps did you walk. Okay, so that every day we are not writing the algorithm. What it is doing it with the past data, whatever the past data, because at 10 p.m. you are getting it from the past data. So when it is calculating 12 a.m. midnight, from the 12 a.m. midnight to the 10 p.m. night, okay, because the day start at the 12 a.m. Yes, 12 a.m. midnight it will start. To the 12 a.m. midnight to the 10 p.m. in the night, how many steps you have taken? It start calculating. Okay, so calculation is done with the how it is being done with the help of the statistics itself. Yes, so this machine learning will help us to uh, give us a variety of knowledge, variety of inference knowledge, conclusions you can get, variety of like whatever you can bring, you can put it with the help of the machine language. You can able to put it from the machine language. Yes. So machine language will broadly classified. Like this is to be remembered. This is to be understand at your side. Like machine learning, we usually categorize into three forms. That is called as supervised learning, unsupervised learning, and reinforcement learning. So, what is like the word? These are the new terms at your side. I suppose I can know, but try to understand what is this supervised learning, what is unsupervised learning, this deep learning, deep reinforcement learning. They are the new terms. Like they have added up in this particular diagram. But actually, we have three broadly categories. That is the supervised and unsupervised. Just try to understand what is supervised is. Supervised learning means where we have the data in the label form. Like suppose data of a give height of a student. So height of a students in a class. How many students are there in the class? Take it as 60 students in a class. So every individual will have its own height. Yes, every individual will have its own height. So that is called as supervised learning because it is labeled. Yes. What is that data I am seeing? That is the height of a student. Yes. If it is not labeled, we are not able to understand because the data are available in a huge amount. In a very huge amount, the data is. Now you can use if people are hearing it. It's a cloud. Everything is there in the cloud. What is that cloud? It's a database where the huge amount of data are being kept. If we try to use the statistics techniques on those data, how can we able to calculate? We need a subset of the data. We need the label of the data. We have to understand what type of data it is. So that's the reason whenever we will be going for the machine learning, we can use for both the labels of the data and unlabeled data also. So wherever when we are using for the supervised learning, we are using for the labeled data. Wherever the labeled data are like height is not given, weight is not given, but the data are given. They are called as unsupervised learning. Reinforcement learning is the middle part of both supervised and unsupervised learning. Now, deep learning and deep reinforcement learning are the subset of the supervised and not like subset. It is a superset of the supervised learning and unsupervised learning. So there are some several algorithms that are being used for the supervised learning. I'm not taking this module the unsupervised learning, why? Because it is a different way of handling the data where the data are not labeled. So when the data will be labeled, it's very easy to understand. That's the reason I have just taken those examples, those algorithms only to make you to understand if the data are labeled, how we can do for the supervised learning and how can able to predict. Because statistics will help me to interpret the data as well as to give me the conclusion, to help me to predict for the future. Is it clear? So these are the very few algorithms I have given here. Well, I'll make you to understand how these algorithms are being used. So this nearest neighbors it is there. So what is this K nearest neighbor? What is this K represent? Okay, so I'll explain you about the K nearest neighbor. Then decision trees. We can able to take the decision. Okay, with the help of the trees, we can able to take the decisions. We can able to go for the conclusion. Then maybe base. We have base theorem. If you remember, like somewhere if you have come across it with the statistics, normally it is being used base theorem. Okay, the probability statistics. So base theorem with the help of maybe base algorithm it is. Then we have logistic regression. So regression 9 also you must heard somewhere else. So there will be a straight line. So how the straight line is helping us to find the to interpret the data and come for the conclusion. And like support vector machines. Okay, so support vector machines is a like you can say that super algorithm. It's the higher part of this algorithm. Okay, so that's the reason one only I have taken into it. We'll try to understand how the statistics plays a vital role in this algorithms in this artificial intelligence. So the K nearest neighbor is also called as KNN, which is a statistical technique that can be used for the solving of classification. Now, what is the statistics I was saying in the starting of my class? It will able to help me to categorize the data. Categorization of what? Classification of data. Categorization of the data. Okay. So it will be helping for solving for classification and the regression problem. So we'll see how the case classifying is unknown object using in the case. So you can check it out by in the given like particular given data sets. My all data are represented in the green color, blue color, and red color. So if I wanted to find out one data, so if a new data is coming, so new data will be going in which part? Whether it is going for the red color part, whether it is going for the blue color part, or whether it is going for the green color part. Okay, so this way will represent what we will do. We will first classify the data, categorize the data. So whatever the data are available, that means the pure data, the history of the data, whichever it is available, or the sample data, whichever it is available, we first categorize into three form. What are the three form? You can check it out. Red color is there, color is there, and the green color is there. Yes. So this diagram, three type of objects marked in the red, blue, and green colors. When you run the KNN classifier, that means KNN classifier is my algorithm. If I run the KNN classifier on the given data sets, whatever the data sets I already have, so the boundaries of each type of the object will be marked. Is it clear? So boundaries will be marked. You can check it out. If suppose the new data is going to come, is it clear? If a new data is going to come, like suppose you just take a basket of ball, we are having three different colors of balls. So you can check it out. These are the three different balls are there. Three different colors of the balls are there. One is the red color balls, the another one is the blue color balls, and the third one is the green color ball. So already whichever the balls are there, it is kept into some categorization. If a new ball is going to come, okay, so what is that new ball? I have to see that. What is that new ball? Is the new ball is a red color or a blue color or a green color or cannot be any color? Okay, maybe some other fourth color. So where you are going to represent, where you wanted to keep that particular data in which particular part? Okay, so KNN will help me to find it out. So we consider the new unknown object. The same I was saying. The new unknown object here it is represented here. The new unknown object I will make it and wanted to classify into the red, green, and blue. Now I wanted to see that this is my new data it is there, and I wanted to keep it into the particular categorization of the data. This is my unknown data. It's a new data. Unknown data is my new data. So as we see visually, the unknown data point belongs to a class of blue objects. I kept it in the blue objects. Why I kept it in the blue objects? Why I kept it in the blue objects? Why? Because I wanted to know that this data, where it is lying, where it is lying. So KNN stands for nearest neighbor. Okay, so when we talk about scale, it is called as a nearest. So this data, this is my new data. This new data, who is the nearest neighbor? So since this data you can check it out in a blue color it is. So that's the reason it is kept in a blue color. Why? Because it is very nearer to the all the data of it. Okay. So we will know that most of the neighbors are of blue color. So average distance of the red and green objects obviously it will be more than the average distance of the blue data objects. So that's the reason the unknown object can be classified as belonging to the blue class system. So KNN algorithm can also be used for regression problem. So regression problem, that regression analysis, we can be able to see that whether that data can lie on a particular line or not, whether that new data can lie, how much far away the distance from the regression line. So the KNN algorithm is available as ready to use in the most of the ML libraries. ML is like machine learning libraries. So this is what is yes, here ML libraries, that is called as the machine language libraries. Now one word is there that is called as K word. We are using always the K nearest neighbor. What is this K? What this K is going to represent? Nearest neighbor, we understand whatever the data is there, whichever the earlier data, the history data is nearer to the new data, that is called as the neighbor data. Okay, so that is called as the neighbor data. So what this K is going to represent? So this K is going to represent the number of nearest neighbor, the number of nearest neighbor. So what is this K represent? So K can be any numbers. So what is that number? K can be equal to 1, K can be equal to 3, K can be equal to 5, K can be equal to 9. So you can check it out in the given slide how it is represented. Okay. So K equals 1 means the new data which I am taking, the new data related to the new data, how many nearest neighbor it is having. So if the 1 is nearer to it, it will represent to that particular group of data. Similarly, if k equals 3, so if a new data is representing which is nearer to the 3 data, 3 red color data or 3 blue color data, whichever it will be the maximum, either the 3 blue color data, so the new data will goes to that particular group of data. So I'll show you one example here. So this is the definition. Again, it is given over in this slide. K-nearest neighbor is a simple algorithm that stores the available cases and classifies the new data or the case based on the similarity. Yes, K-nearest neighbor, when we are talking about this nearest neighbor algorithm, with respect to the statistics, we use similarity. We use similarity data. We can able to see that how the data are similar to it. Is it clear? So you can check it out in this diagram, in this particular picture, whatever it is given over here on this particular slide. We have total 5 yellow color balls are there, and similarly we have again the 5 purple color balls are there. So the yellow color balls are represented as a class A, and the purple color balls are represented as a class B. Now there is a new data came which is represented as a star. Yes, I wanted to check it out how this star is going to represent in the given data set. So the star can goes where? Will it goes to the yellow color of the class, or the star is going to represent to the class B, the purple color of data set. So K will play a vital role. The K value is there, na? That will play a vital role. So I will take, if I'll mark the K value as 3, so I will take that whatever the data, yes, hello, hello, yeah, I'll continue. So I was here like this red color data is my new color data, and the K value is represented as 3. Then I will say that I will take that 3 is my nearest data. So how many data are there? 3 data. So I'll take the nearest 3 data which is nearer to the star. So and now to the nearest 3 data, I have to check that what is the maximum number of nearest one. So you'll see that star in the when the k equals 3, we have 2 purple color balls and one yellow color ball. Okay, so what is the maximum one? So maximum one is 2. So now the star will belongs to the class B. The star will belongs to class B. Now if I'll change the value of k equals 6, so I'll take the k equals 6. So how many values are coming for the k equals 6? You can check it out. 4 yellow color balls are there, and only 2 the purple color balls are there. So now I have to check it out that my new data belongs to which class? Class A or class B? So since we are having maximum of class A, the similarity which I am taking, the maximum of class A. So So that's the reason the star will now belongs to class A. So now you can able to understand what K is going to represent. K is going to represent the value of the nearest neighbor. Okay, on the basis of the K, we have to give the input. What is my nearest neighbor? I wanted to look for it. Yes, like suppose I'm having a friend, 10 friends I'm having. I wanted to check that if the 11th friend is coming. So that 11th friend is nearer to which friend? Which of my 10 friends? I wanted to see what is the address of the 11th friend who is nearer to my all my 10 friends. So I can able to calculate. So clear. I hope these examples will be clear for it. So similarly, this is the same example I have taken here. The k equals 3 and k equals 6. The same example I have explained over here. So this is the similarity. Here I am checking with respect to the statistics. Statistics helps me to uh, compare. Yes, that helps me to compare. That helps me to calculate and give me the predictions. Can able to interpret. Is it clear? So this k nearest neighbor is used with the help of the statistics. So why do we need a k and an algorithm? So if we can take the like number k of the neighbors, calculate the Euclidean distance. So distance is going to calculate as a mean value. Yes, Euclidean distance of the k number of neighbors. Take the k nearest neighbor as per the calculated Euclidean distance, which is the mean value. Among these k neighbors, count the number of the data points in each category. Assign the particular new data points for those particular category, for which the number of the neighbor is maximum. The same algorithm, what I explained you, that is written here. So, how the statistics, now you will be asking how the statistics is going to be play the role in this KNN algorithm, which the madam is speaking. Yes, the Euclidean distance. What is my Euclidean distance? I'm going to calculate. Yes, I'm going to calculate this Euclidean distance. What is with the help of me? With the help of the statistics terminology only now? Yes. So that's the reason. So now my our model is ready. My KNN model is ready. Now with the past data, already my model is ready. If any new data is going to come, the machine will itself try to learn it and put it into a particular classification of data. I hope I'm clear. If any doubt, you can put me in the chat box also. So I will going to the next one, which is called as the decision tree. So what is this decision tree? This is also one of the important algorithm in the computer science where we'll be classifying again the data. It is also used for the classification because the statistics will help me to categorize the data. And this categorization can be done very easily for the classification of data. Yes. So in the given decision tree, the questions are decision modes and final outcomes are links. So you can check it out. Whatever the data I'm getting it now, whatever the data, the sample sets I'll be getting it. That sample sets I'll be taking into the form of tree. I'll put it in a tree. Okay. So what is my tree? You'll be asking what is my tree. So tree is like the main data will be kept in a root node and their parent node will be generated, and with the help of the parent node, the child node will be generated. And at the child node, if we doesn't have more nodes, then the last node will be called as the leaf node. And the last node will be called as the leaf node. So these leaf node will give me the conclusion. We are always focused on the conclusion. We are not focused how we are doing it. We are just focusing on the goal point. We are just focusing on the conclusion point. Yes, we have to always keep this thing in the mind, like what we need. What is my need? So need is my conclusion, need is my goal. Yes. So this coming to the decision tree, we have two types of decision tree, that is the classification decision tree and the regression decision tree. So classification is just based on the categorization. We'll categorize the data into the some form, some categorization we can do it, and based on those categorization, we can able to classify the data. Yes. The second one is the regression tree. So in the regression tree, we all keep on saying, I'm just keep on using the word regression line, because one regression algorithm is also there. That's the reason I didn't spoke till now the regression line. So there is a regression line. We'll be making a straight line, and whatever the data which is lie on a regression line, whichever the data which lies on a particular line, straight line, that are called as the best data. That will give me the conclusion point. So in this kind of decision tree, the decision variable will be continuous in a given particular line. Uh, so this is the decision tree. So this is when data sets is there. I think the data sets I didn't keep. I'll see the next example I have used. There also the same data sets I have used over here. So this particular data set is used. I have to take the decision on the basis of whether I have to play tennis or not. So there will be a one data set will be given, and I have to go for the conclusion whether I can go for the play, I can go to play for the tennis or not. So there will be a data set given as outlook will be there. Outlook will have some of the data set like sunny, overcast, and rain. So, if it is sunny, then we can play or we cannot play. If it is the overcast, we can play or we cannot play. Similarly, if it is the rainy season, like the outlook is rainy, then we can play or we cannot play. So, based on this tree, like based on the given data sets, I have made the decision tree, and I have seen that I can only wherever the value I'm getting as yes, then only I can play a tennis. So, what is my how can I play my tennis with this particular representation of the decision tree? If the outlook is sunny and sunny is having a humidity is normal, sunny is a sunny day which is having a humidity value as normal, then I can go for I can go to play out for tennis. If my sunny is there, humidity is high, very high, then I cannot go for play to tennis. Okay, so this is the decision. You can check it out. These are called as my leaf node. They are called my parent node. They are called as a child node. These are the parent node. These are the child node. And the child node also has child is also become as a parent node and having another node. So whichever the last nodes are there, they are called as the leaf node. Okay, leaf node means they further can't go for it. Okay, they further can't go for any more data. Yes, so with the help of the leaf node I can able to take the conclusion, I can able to decide. Okay, so statistics is playing a vital role. Why? Because it is going to categorize my data, it is going to classify my data. So what is my classification? Outlook is classified into sunny, overcast, and rain. Similarly, the sunny is going to classify into the humidity. Humidity is going to classify again the high and normal. Similarly, the rain, windy rain. So windy is strong wind or the weak wind. So based on this, I am able to classify that whether I can play a tennis or not. So if the outlook is sunny and humidity is normal, I can able to play. Similarly, if the outlook is rain and the wind is very weak, so then also I can play. So this is my decision. It helped me to go for taking the decision, conclusion, and for this we can able to write the algorithm. Then the other algorithm is called as the Navy Bayes. So Navy Bayes is again a classification techniques based on the categorization, which is based on the Bayes theorem. So I hope a little bit idea about the Bayes theorem. If it's not there, I'll give you the formula also how this Bayes theorem. It is based on the probability. Okay, so Bayes theorem is a strong assumptions that all the predictors are independent to each other. So in simple word, we say that the assumption is that the presence of the feature in a class which is independent to the presence of any other feature in the same class. For example, if I'll say that phone may be considered as smart. How can you say that your phone is smart? Your phone is smart when it is having a touch screen. Yes, if it is having a keypad, we won't say that it is my phone is my smartphone. Is it clear? So if it is having like thumb impression, with the help of my thumb impression, it can able to open my phone, then we'll say that it is my smartphone. So if a phone may be considered as a smart if it is having touch screen, internet facility, good camera, though all these features are dependent to each other, they contribute independently for the probability of the phone, which is a smartphone. Is it clear? So whichever the data which is working as a independently, then we say as those are representing to a particular conclusion. So in Navy Bayes, we use the Bayesian classification only. So the main interest is to find the posterior probabilities. That is the probability of the label given. So that is P of L divided by features with the help of Bayes theorem. So what is my P L by features is my posterior probability. Okay. So P by L is my prior probability and P by L by features is my posterior probability. So P of features by L is likelihood, which is the probability of prediction for the prediction of the given class. And P of features is said as the prior probability of the predictor. So base theorem can be expressed as P of x by y, where x and y are the simple events, x and y are the simple events, and P of y should not be equal to 0. So whenever I am taking the P of x by y, like x and y are my variables, are my events, so y cannot be 0. So when we'll take P of x by y, will be represented as P by y of x multiplied by P of x divided by P of y. So what is my P of x by y? It is my conditional probability that is going to occur the event x given the value of y, given the value of y when it is true. So any occurrence of data where the x can be occurred and when it can be occurred when the value of y is true. Similarly, if I will talk about the y of x, then it is a conditional probability that is going to occur the event y when the x value is true. So P of x and P of y both are the probabilities observing the value of x and y independently of each other. So this is known as marginal probability. It's also called as marginal probability. Now based on this Bayes theorem, we can able to calculate. Now the same example which I have said about the decision tree. So my input is play tennis data and output is my prediction model whether I have to go for playing a tennis or not. Okay, so input data set. So consider the data set which will be given here in the playing game of tennis where my conditions are yes and no. Okay, so this is my data sets. That's the reason I didn't capture the decision tree. This is my data set. You can check it out. There are how many items are there? How many days are there? 14 items. That means 14 days are there. And you can check it out. The outlooks are there here. Outlooks are divided into three forms: sunny, overcast, and rain. Again, temperature is hot, mild, cool. Okay, hot, mild, cool. Humidity is again high and normal. Only two things are there. Wind is again two, weak and strong, which I have shown in the decision tree. Now, based on that, I have to decide whether I have to go for tennis to play the tennis or not. So only two data is there, either yes or no. If it is yes, that means I'll be going to play. If it is no, that means I'm not going to play. So how to calculate? How to calculate this with the help of the statistics? So with the help of the statistics, Navy Bayes, the Bayes theorem will help me to calculate. So you can check it out. P of yes is equal to 9 by 14. So if you calculate how many data are there, total D 14. So 14 data are there. How many yes are there? 9 are there. You can calculate 1, 2, 3, 4, 5, 6, 7, 8, 9. So P of y is P of y is 9 by 14. Similarly, how many minus it? You do the P of n, that is no. So 14 minus 9 is 5. So 5 by 14. So now my frequency is that we can play tennis. We can play tennis P by S only 9 by 14 times. This is my prior probability. And no is 5 by 14. Total is 14. And we will see that this should be always 14. 14 by 14, that will be 1. So to play a tennis, we'll see sunny. To play tennis, how many sunnies are there which is having yes? You can check it out. Sunny here is yes. Sunny here is yes. Only two times we are getting the yes. That's the reason sunny yes is taken as 2 and no. How many times the sunny is coming? Total 5 times. Okay. Total 1, 2, 3, 4 and 5. Total 5 times the sunny is coming. So that's the reason 2 plus 3 it is taken. 2 is the yes time, 3 is the no time. And P of yes is 2 by 9 because total it is 9 times the yes is coming. So probability of sunny to be no is 3 by 5. Similarly, I can calculate for overcast. Similarly, I can calculate for rain. Similarly, I can calculate. So after calculating, we can easily calculate for the temperature also, hot, mild, cold. We can also calculate for humidity, high, normal. And similarly, I can calculate for wind, for whether it is uh, more windy or less windy. Okay, so this way we can able to calculate and we can be able to find it out. Wherever you will be getting more yes value, we can able to go for play the tennis. This way we can able to calculate. Now coming to the next uh, algorithm, which is called as logistic regression. It plays a vital role. It plays really because all the predictions, all the hypotheses are based on this logistic regression. Whatever the value we are getting it, we will be keeping on the this hyperplane, or we'll be keeping on this particular logistic line. Okay, so if you are seeing this diagram, it shows the distribution of the data points in the xy plane. Okay, so from this diagram we can easily inspect the separation of the red dots. Why? Because regression line regression logistic regression line is a particular line which can able to divide the two data sets or two class of data. Okay, two class of data here. Like we can able to see that how this regression line is going to uh, do the analysis. Here, whenever we talk about the regression line, we will be looking for the dependent values, dependent variables, and the independent variables. Okay, so in the given diagram, you can check it out. We can visually inspect the separation of red dots from the green dots. Easily, I can separate. Okay, so we can draw a boundary line to separate out those dots. So to classify a new data point, we can able to just need to determine on which side of the line the particular point can able to lie. So I'll talk about this logistic regression a little bit more. Like this, whenever I talk about the regression line, we'll be checking about the regression line equation, that is y equals mx plus c. This is a like a common equation given for the line y equals mx plus c. So what is this y equals mx plus c? Y it is what the y is going to be represented, or what the value this x is represented. Yes. So whenever we go for this regression line, we will be checking what are my dependent variables, what are my independent variables. Some of the values will be called as the outliers, which is not the part of my particular data sets. And whenever we go for the logistic regression, we'll see multicollinearity, how it is related. And also we'll check about like whether the data are underfitted or whether the data are overfitted. So these all the statistics will help me to find it out. The statistics are going to help me to find it out how this underfitting of the data is there, how this overfitting of the data is there. Yes. So I'll give you a small example. Like if in a particular organization, if I am being asked to find it out, what is the annual sale of a given organization, then to find it out the sales of a given organization, I need to do some factors on which factor my sales are dependent. Yes. So in the regression line, it will be taken into the consideration. Like how the dependent variables are there, how the independent variables are related to the independent variables. Yes. So when we talk about like calculating the sales, we will be having some factors f1, f2, f3. Okay, some factors you can take it. How many number of factors you wanted to take? F1, f2, f3, so on up to fn. So my sales value, which is my dependent value, y, will be taken as mx plus c, or alpha plus, you can take it as. Okay, so that will be represented as a regression line, which is going to help me to try to create a model. This regression line will help me to create a model to define the relationship between the dependent variable as well as the independent variables. So how these points are interrelated to each other, how these points are dependent on each other, what factors are going to affect the sales of the given example I said. So this regression line will help me to find it out, right? So I talk about this regression line, this will give me a very what to say, that very solid way to come to the conclusion where it should be lying in. Okay, where it should be lying in. So whenever I talk about this dependent variables and the like independent variables, I'll be writing the formula as y equals mx plus c, or I'll be taking as y is equal to alpha alpha plus alpha 1 plus x1 plus alpha 2 plus x2 plus alpha 3 plus x3, so on. So where my y value will be dependent called as the dependent variable, and x value will be called as my independent variable, because they are the factors, they are independently. But y is my dependent variable, because sales will be dependent on some values. Yes, whether do you have a season sale, whether have you given any discounts, that's why your sales are more. So some factors will be there. So x will be called as the factors and y will be called as my uh, dependent variable. Okay, so this y equals mx plus c play a vital role, and m will be called as the coefficient of the regression. We have to calculate the coefficient of the regression. Coefficient value we can calculate with the help of the statistics. Yes, and with the help of the statistics, we can able to calculate this regression line, and with this regression value, we can able to predict. We can able to say what is my conclusion. Is it clear? So since I have not kept any example because I was thinking when I will be going for this explanation with the help of example, it will go beyond the time. That's the reason I did not kept any examples over here. But I hope you can able to understand with this regression line will help me to find it out the conclusion directly. So the last one I'm going for today's topic, which is called as the support vector machine. So what is the support vector machine and how we are going for support vector machine? What it is? Because the support vector machine is playing a vital role again, and you can check it out. The best example of the support vector machine, I'll give you the example as like Amazon. If we are selecting any data item in Amazon, what you will say the moment you will select any item which you wanted to purchase, automatically you will see at the down only that particular app, the Amazon will always say that another user has also taken some more items with what item you have been selected. Okay, what items you have been selected. So support vector machines is the best example. Today we are using it. Is it clear? Today we are using it. So look at the following distribution of the data, which is shown over here. Here, three classes of the data are there. Three classes of the data are there, which is linearly separated, and the boundary curves are nonlinear. So finding the equation of the curve becomes very complex. So we'll find it out some regression line. Again, we'll draw one regression line. Okay. So now this regression line will help me to find it out. Is it clear? To help me the find it out. So, what is this SVM classification? How this SVM is going to classify? This SVM is going to classify the data, whichever I have selected. That data is similar to another data, which is similar to another data or not. That it is going to be calculated. Is it clear? So this SVM classification again use the statistics. Again use the statistics of the regression line. Again use the statistics of the regression line. So this regression line, what it is going to help me? It is again going to give me the conclusion part. It is going to help me to do the prediction. It can help me to go to find it out the final goal of it. Whatever the class of the data it is there. Okay. So how this SVM is going to work? So SVM like how it is going to work. So what we will do? We will draw one straight line. We'll first draw that straight line. Like you can check it out here. It is the data are there. So here I will draw one straight line. Now based on this straight line, I can able, because this line when I'm drawing this straight line, I can able to classify the data into two parts. Now for the first part, I will take a small vector of the data, and that I will keep nearer to the particular line which I have drawn. That is the regression line. So that regression line will fall as a hyperplane. So from the first part of the data, one small vector I'll be taking it. That vector I will select which is very nearer to the opposite data. Okay, and then again one parallel line I will draw. But again parallel line I will draw. So now this parallel line will help me to find out the distance between the hyperplane, the line, which linear line I have drawn, regression line I have drawn. Okay, so this line I will draw. Now this distance will help me to find it out what is the minimum distance. Similarly, for the other side of the data, again I will take the small data, one vector data, one attribute of the data, which is closer to the opposite data sets, and again I will draw a parallel line with respect to the regression line, and again I will calculate the distance. So this distance will be helping me to find it out which particular regression line is the best line to divide this data. Why? Because I can draw the data in like slanting way. I can draw the data. I can draw a line in a vertical way. I can draw the line in a horizontal way to divide the data. But which is the best line to draw it? Which is the best regression line that can separate my data? Why I am trying the regression line? I am trying the regression line just to separate the data, do the classification, do the categorization. Once the categorization can be done, we can easily able to predict. Is it clear? We can easily able to predict. So this way the support vector machines is being used. So here some of the examples for the algorithms I have kept from the computer science, how statistics is totally dependent on today's world. Everything is dependent on the statistics. The small, the basic terminology I use, and I came up to the regression line. And this from the mean, median, mode, so many terms I have used over here: variance, correlations, standard deviations, so many terms I have used. But those terms are directly related to us in the daily life, and that will help us to take the decision. That is going to help us to take the decision. So I'm going to the conclusion of it, like what I spoke today in this session. So the conclusion of my today's lecture, which I wanted to give, which I wanted to give the information at your side, like statistical department is very important. We are interrelated to each other. As I am from the computer science, but we cannot go apart. Okay, we have to work together because we are interrelated to each other. Because of this statistics terms only we can able to get more information. What is my conclusion? If I'm always talking about, I'm going to get some conclusion. What is my conclusion? Conclusion can be new knowledge. Yes. For example, the latest example I can give you, like the NASA has launched again. The NASA has launched a particular satellite. Okay, so particular satellite which the NASA has launched has got failed. So what is the reason to be failed? What is the reason to be failed? So based on those reasons, I will be taking for the prediction for the next time. If I'm launching the next time a new satellite, I have to take care of it based on those negative problem, which the issues which was failed for me. I'll be taking into it, and so that I will do a much better prediction for the next time. I will be knowing it. It's not necessary that always we will be getting the positive conclusion. We should have a negative conclusion also, because of this negative conclusion we can't compare which is better. Yes. So selection of the appropriate statistical methods is very important. Which should be noted, which is to be required, which one to be used where, that should be well known. Once when you will able to understand the statistics very well, then you can able to use those statistics in any area of the life. Okay, any area of the daily life, any area of the global, wherever you are using it. It is important to know the basic concept of the statistical method, which is used to conduct any analysis that produce a valid as well as the reliable result. There are whatever the statistical methods I have mentioned in my module, in my session. Not only those methods, there are many other terms are there which I have left over it. Only the base one I have taken, that will be used in the different situations. So each test makes particular assumption about the data, and these assumptions should be taken into the consideration when we are deciding the most appropriate test to be done. Is it clear? So the wrong statistical method or the inappropriate statistical method which you are going to lead, which you are going to take, it will give you what type of conclusion? Some negative conclusions. Yes. So finally, we'll what we will do, if we will take wrong interpretation, if we take wrong statistical method, obviously my conclusions are going to be wrong. So finally, what we are going to be have, we will harm our evidences. Yes. Like suppose I am taking the wrong interpretation, wrong statistical method I am using for the medical side, and I wanted to calculate whether a patient belongs to a cancer patient or not. So statistical method to calculate it, I will be giving the wrong interpretation to the patient. Yes, whether the patient is a cancer patient or not, I am not able to give it. I will not give the proper way of to say the final conclusion. Yes, so hence it is very necessary to educate knowledge of the statistics needed to be required. Appropriate use of the statistical tests are very important that will help us to improve as well as to produce the quality of the data. So it is extremely difficult for any researcher, any academician, or any person in the world who can learn the entire statistical method. It's not easy to learn for anyone, but the main one, the through which we will start doing the analysis, that can be taken into the consideration. So at the least, I'll be saying that basic knowledge is very important so that the appropriate selection of the statistical methods help us to find it out the correct as well as the incorrect practices that to be done in the daily life. So here I'll stop my session. If any doubt you are having, you can ask me. I'm here. I'll be checking out the chat box. Is there any chat box over here? I can check it out if any questions are there. You can put me the questions over here, which is related to today, what I have given.